How fast can I explain the basics of Calculus 2? Let's find out. So you want to know how to integrate in Calculus 2, and integrals are just antiderivatives. So rather than subtracting one from the exponent, you're going to add one, and then divide the entire number by that exponent. Now, if your integral is indefinite, you're going to want to do a plus c at the end of this. If your integral is definite, meaning that it has boundaries on it, a lower and an upper one, then you don't need to add a plus c at the end. So let's try a definite integral. Now, the way that we can do a definite integral is using that power rule, where I add 1 to the exponent and then divide the whole thing by that exponent. And since we see a constant here, I can just slap an x on. So if I run these numbers, I should get 3x cubed over 3 minus 100x bounded from 3 to 5. Now I can cancel the 3's right there, giving me x cubed minus 100x bounded from 3 to 5. I can plug in the 5 where I see x, and I can plug in the 3 where I see x, and then subtract the 2. So plugging in the 5, I'll get this value, which will evaluate to negative 375. Plugging in the 3, I'll get this value, which evaluates to negative 273. Now, if I subtract that, I get negative 102. And that right there is the integral of this function up here. So let's now try an indefinite integral. And an indefinite integral is where we have to do a plus c. But notice that I have a function within a function right here. So this is going to be a little bit hard to deal with. So what I'm going to want to do is something called a u sub. And a u sub is where we make part of our function equal to u. So in this case, I'm going to make it that 3x within the cosine. Now, what I can do from here is I can take the derivative of u with respect to x, and that's going to just derive off this x here, giving me 3 dx, because we took the derivative. Now, if I divide both sides by 3, I'm going to end up with dx is equal to du over 3, which means I can take this term and I can plug it in for this dx. So what I'm going to have is du over 3, because this is all with respect to u now. But this 3 will cancel with this 6th term is 2 times 3, so I can cancel a 3, and this will leave me with 2 integral of cosine u du. Now all I need to do is integrate this cosine. And the integral of cosine is going to be the sine. So what I'll have is I'll have 2 times the sine of u plus c. But now I need to put my u back into my expression here. So I'll be left with 2 times the sine of 3x plus c, and this right here is the indefinite integral of this function. Now, what if all else fails and we want to use is this formula, which is the integration by parts? Notice that a u sub isn't really going to work here. So what we need to do is assign one of our variables to u and the other one to dv, and that's going to match the u and the dv we have up here. Now, what we can do is we can take these and list them out, and then we can take the derivative of u. Derivative of x with respect to x is just going to be dx. And then the integral of dv, so if we take this term and we integrate it, what that's going to give us is negative cosine, because the integral of sine is negative cosine. Now we can just plug it in to the formula you see on top of the page. And what that's going to do is give us that. We can go ahead and cancel this negative sign with this negative sign, and we can integrate this cosine x dx. What that's going to give us is this final answer right here, and we want to do a plus c, because notice that this is not a definite integral right here. Now finally, these are some common integrals that you're going to see throughout your Calculus 2 course. That was a basic introduction to Calculus 2.